Everyone, so in this video, I'm going to talk about like searching algorithms. This playlist is all about the searching algorithms, first of all, we'll talk about what is searching algorithms, and then we have to jump into the linear search algorithm, which is the very easiest searching algorithm you can find. Okay, now first of all, we'll be explain the searching algorithms as we did for the sorting algorithms, and then we jump into the time complexity of the searching algorithms, like the linear search for this video, and we will code the linear search algorithm and the applet. Okay, so that's the like the intro you can say. So let's jump into the linear search. Okay, so talk about the linear search algorithm. Linear search. So before talking about the linear search, first of all, we have to talk about what is searching, right? What is searching? So searching means the word the word is actually like explains everything. The searching means finding something, right? Searching for something. So in programming, what do you mean by searching? Programming, the searching means searching for an element, searching for a data, right? So actually in programming or in like in computer science, we are working with the datas, right? Like the lots of datas. So that's genuinely the searching do. It searches for an element. It finds a specific element from a like the large collection of the data. Okay, so like that's what is searching is. And if you say why we need searching, then it's simple. Like the answer is, you can say like we need searching because sometimes we want to find a value, right? Sometimes we why if you're a person and you want to like call a specific person, you'd go to phone and you go to the your contact list and you search for that person, right? So searching really does um, use like use in the real world also. Like we daily use it. Like if we can maybe use it in the phone, we can maybe use our like Google, typing something in Google, that is also a search. And maybe we are going to Instagram and we search for a particular person, and after clicking that person, we're getting that profile. So searching do really there in our real world. Okay, so that is actually searching. That is why we need searching. It is very important part actually, but quite an easy one. It's very easy, you can say. And if it's of the linear search, it is definitely like just easy one. Okay, so let's start with the explanation of the linear search. Suppose we have a list of elements. Suppose we have a list of elements like an array list. Suppose we have a list like 3, 2, 1, 4, 5. Uh, okay, this is the list. This is an unordered list. Suppose we have an unordered list and we want to search for an element in this list. Like we have to search for an element 4. 4 is our target. 4 is our target element. 4 is our target element. Okay. So what will you do? What will you do? Suppose we want to want to get the index of the element of the element 4 in this list. We want to want that where this 4 is lies in this list, is in this particular list, in this particular okay, sorry, uh, in this particular list. Okay, lies in this particular list. So how do you do that? In case of linear search, it's very simple. We just have to like compare each of this element in the list with the 4. If it get like equal, like we get 4, then like just return that particular index and we don't have to do anything else. Don't have to. But it is that simple. So if it's about the 2, if it's with the 4, we want to search for the 4. So what it'll do first, it will start from the first index. So it's in 0, 1, 2, 3, and 4. This is the indexing. Of course, index starts from 0 to n minus 1 in the list or an array. So if it's about the 4, it will first compare with 3. It will check if like the target element target element is equal to like the lists element. Like if it's about the list, it's a list element. list, I can say element. Okay, this name I'm preferring, and if it finds a like match, then it will just return its index. Return its index. And if it's and after searching to the whole list, if it doesn't find any match, maybe it will return -1. Okay, so suppose it is just search for it, and then like it said, okay, is it equal? So it's no, so it will go to the next index. It will check for next index. So again it will go, so it would say no, so it will check for the this. So it will say if 4 is equal to like 2, it will say no. 4 is not equal to 2, so it will so 4 is not equal to 2, then it will again go to the next index. So it will say if 4 is equal to 1, so it will say no, it is not equal. So again it will go to the next index. So it will say okay, if 4 is equal to 4 is yet it does, so it just return that index, so it don't go further. So that's the like the time complexity. Sorry, that is the explanation of the linear search. And if you get familiar with the time complexities, you just figure out what is the time complexity is. The time is very straightforward. It is really big of n, right? So if you don't know, I'll explain it here only. So that's the linear search. That it is that simple. I hope you understand it. If you don't understand it, I code it, and then maybe you can get it more clear. So let's get with the time complexity of the algorithm. Time complexity and space complexity. So time complexity. So if you look at the time complexity, so the linear search searches for an each element in the array. So if it has an n element, suppose it has a n number of elements. So here it is 5, but suppose we have an n elements. So the comparison will be n times in the worst case. So if the element is, suppose here the element is 5, we have to search for the element 5, so it will traverse to the whole array, right, whole list. So the in the best case you can say, so not best case, in the worst case time complexity will be in the worst case, we'll see what is the worst case, base case, average case means. No worry for that. For now, we will understand what is the baddest time complexity that this algorithm can have with the worst one. Okay, so worst case, in this case, worst case is big of n, and suppose because it is traversing through the whole list of n elements. Okay, it has to traverse the whole list. That's why its time complexity is big of n. And in the base case, suppose we want to search for 3. So in the first case, first thing only, it will find it, right? In the first comparison only, it will find it. It will find it in the first search only. So if this one is 3, if you want to find 3, in the first case only it will find it. Okay, so so suppose we didn't write it, so it will return what? Return 3. I forgot to write return index 3. Okay, so so here, so in the best case, the element to be searched is in the first index. So the best case, in the best case, it is genuinely big of 1. And if suppose it is average case, we don't want to like see the average case, because it is just something different from the worst case by a constant. So we have to eliminate the constant, it will ultimately become as the same as the worst case. So basically, let's see the average case. Average case, suppose it will lie in some middle, like the 1 in the middle of the list. So if it's the 1, then its time complexity will be halved. So this is if the n elements. So this is if the n elements. Okay, sorry. So this is n upon 2, and this is n upon 2, right? So we have to traverse only through the n upon 2 elements. So actually, its time will become the number of steps is basically n upon 2, but we have to remove the constant, and it will become big of n. Ultimately, the average will also become big of n. So this is the time complexities of the linear search, which is not very good like compared to the other linear search like binary search. We will do in the next video, and interpolation search and stuffs like that. but it is like very simple to understand. Okay, very simple to understand, very straightforward actually. And now if you talk about its space complexity, it is also straightforward. Space complexity. So since in this algorithm we do not use any like the auxiliary spaces, any extra spaces, that's why you can say its space complexity is constant, because we don't need anything extra. Like it is straightforward, like comparisons happening, and if we found a match, we're just returning its index, nothing extra is here. So its space complexity actually is constant. Its space complexity is constant, which is basically big O of 1. It has a constant time as space complexity. So that's the whole explanation, and the explanation of the time complexity and the space complexity of this algorithm, like the linear search algorithm. So now we'll be jump into the code of it. We'll see how like it works in case of the code, and then yeah, and then we finish the video. And in the next video, we'll be talking about the binary search, which is basically an interesting like searching algorithm. And like in this playlist, we'll be first doing all the searching algorithms, like from the common searching algorithms to the tedious searching algorithms, and then we'll be doing the questions on searching algorithms, like from the big companies like the Amazon, Facebook, and also the questions like that are important to do, that are important to build a concept in searching, and yeah, that's all. So let's jump into the code of the algorithm. Let's go to the code. Let's go to the Replit, and yeah, here we are. So let's go to the CodaGo folder. Here, like my YouTube channels, all the coding part is here. You can find here only. So let's make a new folder on searching, searching. Okay, create folder. Now let's make a REPL here. We'll be using Java. By the way, if you want me to code in some other languages, you can comment it out. We'll be doing in other languages also, like Python, C++, if you want it. By the and the that part, the data structures part, I'll be doing in Java also, and in like C++ also, because in some like not C++, it will be C specifically, because maybe some students will get like confused when working with the pointers in C, like to making the linked list stacks and queues in C by using pointers. So I'll be doing because in Java we'll be doing in the classes, so that is quite easy. But maybe for some students, the pointer concept is a little bit of tedious. That's why we'll do both. No, okay. So let's start with this linear search. Create the REPL. Okay, here we are. It's taking a little bit of time. No worries. Yeah, that's the code base. Now let's start with the code. Okay, so suppose we are like initializing an array in ARR is equal to new int of some numbers like 3, 1, 4, 4 and 2, 5, as in unordered list, as like in random numbers. And we are initializing a target. Suppose we need a target equal to, suppose we need 2 2 and want to get 2 actually, like what is the uh, index of the two element, like value 2 element in this array ARR. Okay, so how to do that? Since we have to traverse to the first element to the last element in the array ARR, so of course we need a loop. So we need a loop traversing through the, you can say traversing through the array ARR, and this is the just coming out for your reference. The target element we have to find. We have to find. So let's use a loop. for loop is less than arr dot length I plus plus. Okay, so so we make condition if target, or if you can say arr of I is equal to the target. That means if it's equal, then what have to do, we just have to just print system dot out dot print ln, just we have to print. Or since we are doing it in a like in the main function only, so we can make a check, so that would be easier. So int check, also not int, boolean check, boolean check. So false, first of all we can make it false, like target not found, target not found till now, till now. So here, so if we found the target, so we'll like update the check variable with true. uh, Target is found, target is found now. And after getting out the like loop, and after basically we found the target, we just have to break from the loop, because we don't have to check further because we found the target already, right? So we have to just have to break from the loop, break from the loop. And after getting out the loop, we check if like suppose we are doing here if we found the target or not, right? If we found the target or not. In the later, like later I will be doing like what is the index of the target. So I'm doing check uh, if check, like if it's true, so we'll do system dot print ln. So it is, we found the target, we found the target. And else, in the else part we're doing system dot out dot println, uh, target is not found, target is not found. Okay, so we're talking about four, like two actually, we're talking about two. So if we run the code, so what you'll get, so yeah, it's a, we found the target because two is in the list, right? So it have to say we found the target. But if we change it, it's seven, like which is not in the list. So what it'll give, it will give, target is not found, right? Let's see. Yeah, target is not found. Okay, so now let's code something different. In this code we are just checking is the if the target is there in the list or not. Now let's code another one which will be returning as like a function for the searching, will be returning as the index, like an index of the target, right? Index of the target in the array. Suppose suppose just same, what we do, return this like this is the basic one to check, basic one to check. The basic one with the check, with the check. I'm commenting it out because if you want it in a letter, like for your reference, you can like find it here only, static end. And suppose we are doing linear search, okay, and we are getting an array, we are like taking an array and we are taking a target element. So it's simple, the function will be simple, function will be, it will say we just copy it. So I think that we just copy it, it's just same, just we have to return it when we found out target. So it is same, like yeah. And so suppose we have like found the target, so just have to return the like index of the target, that means I, return I. And after, if it didn't return the target, so at the last we'll return -1 because it can't find the element, right? By traversing the whole list, then also it can't find the element. So it will be -1. Now here calling the function linear search. Okay, so here we're doing system dot out dot println, and we're doing linear search. mm, like calling with the parameters, and here okay, not 7, it's target. Okay, target. So first of all, it is 7. 7 is not in the list, so it should return us -1. Let's see. Yeah, it returned -1. Now if it is like we think 4 here, let's run it. The index will return 2. So it is 0. It is like here is it is 0, 1, and 2. Okay, so it returned 2. That means the program is correct, right? So that's the easier. Like it is quite easy. It is very easy searching algorithm. It is very easy to understand also. Okay, by the way, we'll explain how like the functions and the static whatever the return type and those kind of things. Like if you don't know how for loop works, I'll be doing in the Java course. So don't rush for that. That's the whole video actually. That's the whole video of the linear search. In the next video, I'll be doing the explanation and the code of the binary search algorithm. And yeah, that's all. So if you like the video, share with your friends, subscribe to my channel, and like share it in Twitter, LinkedIn. And if you're learning in public, then take a screenshot of the video and share in Twitter, Twitter and LinkedIn, and in your Discord channels if you have if you are in a community. And also like the share with the hashtag learning with Ronak. That would in that case I'll be glad. And if you have any questions, you can comment it out in below, and you can check out the description for the source code of this video. Okay, that's all for today. See you in the next video. Bye bye.